we're going to integrate 2 times the square root of x squared minus 1 with respect to x for x greater or equal to 1. The fact that x is greater than or equal to 1 simply means that the integral is defined. Now, when you see something like the square root of x squared minus 1 or the square root of 1 minus x squared in an integral, you should think of substituting either x equals cos u or x equals cosh u. Well, in this case, if we used x equals cos u, we would get cos squared u minus 1, which isn't very helpful. But if we substitute x equals cosh u, we get cosh squared u minus 1. And that is helpful because, if you remember, we have the identity cosh squared x minus sine squared x equals 1. And that means that cosh squared x minus 1 is equal to sine squared x. In our case, that means that cosh squared u minus 1 would be sine squared u. So let's make the substitution x equals cosh u, and of course we also need dx by du, and that is equal to sine u. Back in our integral, that means we're going to get 2 times the square root of cosh squared u minus 1 times sine u, all with respect to u. By the way, it's perhaps worth noting at this point that our u is going to be greater than or equal to 0. That's fine because cosh u is an even function, so we can take either u less than 0 or u greater than or equal to 0. We're going to take it greater than or equal to 0. Back to the integral. Cos squared u minus 1 is sine squared u, so the square root is just sine u. So we get 2 times sine u, and then we've got another sine u, so that's going to give us sine squared u du. Now, you'll be familiar with when you integrate sine squared x, say, you use a formula involving cos 2x. Well, the same applies when it's a hyperbolic function. Let's just go and look at the identities again and see how that works. Well, we have an identity, cosh 2x is equal to 2 sine squared x plus 1. So 2 sine squared x would be cosh 2x minus 1. Back to our integral, which of course has now got u's in it rather than x's, but we can still use that identity to rewrite that as cosh 2u minus 1. And now we're integrating with respect to u. Well, that's straightforward to integrate. We get sine 2u divided by 2 minus u, and of course we have our constant of integration. This was an indefinite integral, so we need to put it back in terms of x. In order to do that, I'm going to rewrite sine 2u as 2 sine u cosh u, and of course the 2's cancel. And we can then observe that sine u, well, that was the square root of cosh squared u minus 1, which back in terms of x is x squared minus 1. And cosh u, we already know, is x. What about the u? Well, we've decided that u was greater or equal to 0, so we can take the inverse function of cosh and write u as cosh to the minus 1 of x. plus c. Let's just sketch cosh-u to confirm that that all makes reasonable sense. Well, cosh-u looks like that, where that number there is 1. So we're using this half of the function for our substitution, the part where u is greater or equal to 0, and so cosh-u is greater than or equal to 1. And because we're just using that half, we can indeed take the inverse function.